Hello, children. Now let's move on to the activities, like from acids and bases chapter. So, in the previous classes, we discussed about properties of acids, like uses of acids, and the types of acids, right? And their chemical formulae, as well as bases also, like properties of bases, their uses, where they are used, and what are the chemical formula of the bases, and which kind of bases we are going to mostly discuss in this particular chapter. So all those basics are completed. Now here the activities part. Okay, so now here is first activity given in your textbook. So please children focus on this. Why? Because this activity is not limiting only for the laboratory purpose, but it is something like it can be asked as a 4 mark question. So all the activities are important. So don't only confine yourself to the questions which are given behind the textbook. It is not necessary that he has to pick a question from there only. So all the activities from complete textbook are very very important. They can be asked either as 2 mark question or 4 mark questions. So please see the sequence, and also note down the points which you have to mention while you are writing it in a 4 mark question. So here the first activity is asking us to collect some samples of acids as well as bases in a science laboratory, and he is asking us to take the watch glasses and put a drop of the solution in each one and then test the solutions as follows. Right, that means he has taken the acids as hydrochloric acid, sulfuric acid, nitric acid, acetic acid. So these are the acids. And when it comes to bases, sodium hydroxide, calcium hydroxide, magnesium hydroxide, ammonium hydroxide, and potassium hydroxide. So please, all for easy understanding, whenever hydroxides are there, then they are bases. So you can remember just like that also, because bases have OH minus and acids have H plus ions. Right? Acids have H plus ions and bases have OH minus ions. So therefore, almost all the time, whenever you see, whenever you get a confusion, like whether it is an acid or a base, so hydroxides, whenever there are hydroxides, then that will be mostly that will be of a base. Okay, so now he's asking us to collect all these things, and then now take 4 watch glasses and put one means each time you are checking with one particular solution. Now after taking the 4 watch glasses, suppose if you are putting hydrochloric acid in all 4, now let us make these following tests. Dip the blue litmus paper in the first watch glass. Suppose you are taking hydrochloric acid, first one, you are dipping the blue litmus paper, and we know that it is an acid. HCl is an acid, and blue litmus will convert into red. So therefore it converts into red, and if you get that as a red one, then you can say that it is acid. Now dip the red litmus paper in the second watch glass. So second watch glass also you have HCl only. In that you are dipping the red litmus paper. It remains red. Red remains red. Okay. And now when it comes to add a drop of methyl orange. So when methyl orange is there, so whenever it is like a methyl orange you are doing it with, so slowly that orange color will convert into red color, right? And add a drop of phenolphthalein in the fourth watch glass, it remains colorless. So phenolphthalein remains colorless in the acid, right? So suppose this is how we are going to write the conclusion, like how to make the conclusion. So for HCl, that is an acid, therefore almost all the acids will be getting the same results. Okay, so you can make a column of it, write down the results. In one column you can mention the names, and in the next column you can mention what tests are performed, and in the next column what result you got it. Right, now suppose if you take a base, say like sodium hydroxide, right? You are taking sodium hydroxide in all 4 watch glasses, and now you are dipping, you're making a solution of sodium hydroxide and then making it. Now dip the blue litmus paper in it, so it remains blue. If you dip the red litmus paper, it converts into blue, right? And methyl orange, it will convert into yellow, and then next phenolphthalein will be converting into pink color. Okay, so these are all the things that will be same for all the other bases also. For all the other bases also. So now what's your thing that you have to mention these? Like instead of writing in a single lines, you can mention like what are all the chemicals that you have taken in like 1, 2, 3, 4 from acids, or 1, 2, 3, 4 from bases. Then you say that take 4 watch glasses and take each solution one time in all 4, and then perform the following. Then these are the outcomes, or this is the result of the experiment or the observations. Like that you have to mention, and then in a table of all these columns you have to show the results. Okay, so this is how you have to make a note of that. And just now you can see how to tabulate the results. This is how you are going to tabulate the results. So please take a screenshot of this, and this is how it is you are going to show like what are all the acids and what are all the bases. Now after the table you can write a conclusion that based on the results we can say that HCl, H2SO4, HNO3 and CH3COOH are acids, and then NaOH and the remaining OHs are all are bases. Okay children, so take a screenshot of this. And the next activity here is like natural indicators, about natural indicators. Okay. So here he's suggesting us to take chopped onions and then take them in a plastic bag along with some clean cloth. So tie up the bag tightly and keep it overnight in the fridge. So whatever the order that comes from the onion, so that will be now absorbed by the cloth, right? Those pieces of cloth. Now, after like removing those pieces of cloth, like we have to now test by putting few drops of dilute HCl and then few drops of dilute NaOH on the other, and we have to record the conclusions how and what is happening with the order. Okay, so now let us see what happens. So when it comes to onion, right, we know that it has a characteristic smell, right? When a basic solution, like that means when sodium hydroxide is added to a cloth strip treated with onion, then onion smell cannot be detected. That means what is happening here? By like that means that onion smell disappears now. Now, if you are putting like HCl drops, right, treated with onion extract, a characteristic onion smell is not destroyed in acidic medium. So that means in basic medium, the onion smell is destroyed, and in acidic medium, the onion smell is not destroyed. So thus it is observed that onions have characteristic smell in acidic medium which is completely destroyed in the basic medium. From this we can conclude like onion also, because of its order, with the help of its order we'll be able to know that whether the given solution is acidic or basic. So what is the conclusion that you can say? That onion smell will get destroyed when it is put in basic medium. Clear children? So this is what the conclusion you have to remember. And then acidic medium, of course, it gives that characteristic smell out. So suppose if you are taking vanilla and essence also, so that's not given in your textbook, or he may ask like whatever is available with him. Based on that he may ask. So vanilla essence has a characteristic pleasant smell that we know very well. So in sodium hydroxide, if it is added, then we cannot detect that smell. So that means even in case of vanilla essence, you can see that when it is a basic medium, that smell is destroyed. Right? And now, whereas in acids, it remains. Thus, we observe that vanilla essence remains its smell in acidic medium but loses its smell in basic medium. Now, let us see about clove oil. Right. So now, you know the order of the clove oil. You know the clove that will be available in your kitchen itself. Right. So now you are putting hydrochloric acid solution in one test tube and of dilute sodium hydroxide in another test tube. Add few drops of flow oil in each of them. We observe that different order is obtained from the two test tubes, right? So therefore, based on the order, you can just conclude like which kind of solutions are used, whether acidic or basic solutions. Okay, so those who want to have an extra information than your textbook, please take a screenshot of this. So this one you can make a note in your classwork. This very very important. So now we are proceeding to the next activity just by using posing a question like why pickles and sour substances are not stored in brass and copper vessels. Not only brass and copper, any metal vessels, right? Even in aluminum we won't put. Okay, so now here the question is why pickles and sour substances? You know that sour in the sense those are acids, right? They have acidic characteristics. And why are we not going to store these in metallic vessels? So this is the question. You know it already from properties of acids that acids react with metals. Now let us see how the reaction takes place. For that, this is the diagram that you are supposed to draw. Okay, please look at the diagram properly, and you have a retort stand to which test tube is fixed. In that you are taking zinc granules and diluted HCl, right? And then with the help of a cork, a delivery tube is fixed to it, right? And that tube is let open into a beaker of soap water solution, right? And now as the activity starts, that means so you will be taking HCl into this, and then when you have dropped zinc granules, or take zinc granules first and then drop diluted HCl into it, then slowly the reaction between the metal and the acid starts, and you can see that some gas comes out of it, and that is through the bubbles which are coming out of the soap water. Here you can say that some kind of gas is coming out of the delivery tube. So now to test the kind of the gas here, you are just trying to put a matchstick here or a candle, a glowing candle, then you can see that so it will be blown off by some kind of pop sound. So that pop sound makes us confirm, like it confirms that the gas that is emanated out or it is coming out of the delivery tube is hydrogen gas, right? So it will be put off with a pop sound, right? So that bond is breaking there, therefore that pop sound you can hear. Okay, so this is this one you can write in your own words. Take a retort stand and then all the points. Take a retort stand can be the first point, second point, and then fix it with the help of a I'm sorry, fix it with a test tube, and then with the help of the cork you can then fix a delivery tube from the from this uh, test tube to the soap water beaker. All these points you can write on your own. Okay, so and thus you can give the conclusions. And now let's see how to write the equation part. After writing the like what are the devices that you are using, you can write the procedure like this. Set the apparatus as shown in the figure. Take about 10 ml of dilute HCl in test tube and add a few zinc granules to it. That you have to drop them very gently. So like then on the surface of the zinc granules you can see that some gas is coming out, and then past the gas being evolved through the soap water, right? And that is taken in the beaker. So now here the bubbles are formed in the solution. Don't write like these questions. This textbook person is making us to like realize what is happening, right? Okay, so I love the gas to pass through the soap water and the bubbles will be coming out, then that shows that the gas is coming out. And now you can see that notice that evolved burns with pop sound indicating H2, right? uh, Now, chemical reaction of the above activity is so hydrochloric acid plus zinc gives zinc chloride plus hydrogen. See, children, here I want to explain. You all know, I know that you all know, but even then I'm saying again especially to Venkatesai and Kartikeya, Naina and Shulamiti. So here, hydrogen will never exist as H alone. So in free state, hydrogen exists as H2 always. To have H2 here, right? To have H2 here, you should multiply HCl with 2 here. Then only you will have 2 hydrogen atoms. So here when you are multiplying HCl with 2, then here you have 2 hydrogens and 2 chlorines. And here 1 zinc. Now you can see the chemical formula of zinc chloride. Zinc chloride, Cl2 is needed here. Here Cl2 is needed, here H2 is needed. Therefore you are multiplying HCl with 2. Hence it is a must for you to write 2 HCl plus zinc gives zinc chloride plus hydrogen, and since it's a gas you have to mention all these things. H2 within brackets gas, and this is aqueous solution of zinc chloride, and this is zinc as a solid because you are taking zinc granules, and 2HCl it is also a solution, therefore it is aqueous solution, right? So this is how you have to write the equation. And then now repeat the above experiment with some other acids like. So it is not necessary that always HCl only is taken, right? Depending on the question, suppose if they ask or specify the acid name, you have to mention the same acid, and then you can conclude saying the other acids can also be taken, and the same experiment can be performed, and you will see that hydrogen gas is emitted. So what is the conclusion that you can give? Then finally write the conclusion as that metals react with acids react with metals, giving out metal salts and hydrogen gas. This is one of the property that we have already studied under properties heading, and now this is an activity for 4 mark question, which is very very important as well as very easy. You need to practice the diagram. Okay children, here is the third activity from your textbook, where here he is asking us to perform the same experiment, right, with sodium hydroxide. What is hydroxide? It means that it is base. Sodium hydroxide is base. You are taking again zinc metal, so you are doing the experiment here. You can see that the same thing again, hydrogen gas is coming it, right? Sodium zincate solid is formed here, like salt, metal salt is formed, and here is the zinc is the metal, this is the base. So if at all the question is asked to show that like a base on reacting with the metal can produce hydrogen gas, I see many of the students will be writing this part only, keeping in mind that only this is given in the textbook. No, this is not the way. See, because he had already discussed the same with the help of an acid in detail in the above activity, thus he is giving only a conclusion here in this. So what's your job here? Your job is to write all that again, like the apparatus setup, and then next the procedure, and then next you have to write the equation and then conclude. Okay. Remember that one, children, please. Don't write only these 3 lines and say that, ma'am, only this is given in the textbook, therefore I wrote that and you have to give me marks. Okay, I'll give marks. No, I never mind, right? Because those marks are not the one which are going to help you out, because it is the public examination. You are going to appear for public examination. The one who is evaluating your paper must be satisfied. It's not my satisfaction, right? Right. So please remember that one, children. So here for this activity, you have to write in detail all the steps. Like first you have to draw the diagram. In the diagram, in place of HCl, you have to say that dilute NaOH has to be taken. And then zinc, of course, zinc granules you are taking. And then next in the bubbles, hydrogen gas is evolved. Remaining all is the same. Only in place of dilute HCl. In the previous activity, you have to mention about dilute NaOH, and you have to write this equation and then give the conclusion. Okay. So with these 3 activities, I am stopping this class for today, and please read immediately. This is totally theoretical and really very very interesting. Point by point you have to write the same, and whatever properties you are discussing in acids, the same almost you will be finding in the bases also. So not much difficult chapter, very easy to understand and very easy to remember and reproduce.